As promised before, today we're going to look at a specific family of functions called the absolute value function. And we're just going to, on the graphing calculator, take a look at what the absolute value actually looks like. Now, in order to get this to work out, I'm going to shut off the plot by arrowing up and then hitting enter when it's flashing on plot 1, and that just turns it off. If it's not highlighted, that means it's turned off, and whatever data is in your lists will not be graphed. Now, to get to the absolute value function on your calculator, we're going to go to Math, and then scroll over to right arrow over to the number, and it's the first option. The ABS stands for absolute value, and hit enter, and then that pops up in the Y sub 1. Now, those of you with the new operating system will probably actually have the absolute value symbols there, the straight lines on each side. And once again, to put in X, we hit this variable button that's right next to the alpha button. So we have absolute value of X. And then we're just going to take a look at this on the standard window. So we can actually automatically go to the standard window by hitting zoom 6. And what the standard window is on the x-axis we go from -10 to 10, and same with the y-axis, -10 to 10. So you will see that the absolute value function, the basic absolute value function that we call the parent function, is a V-shaped graph with its vertex, that's what we call the bottom point, or sometimes we have the top point, is we have that vertex right at the origin. So we have this table, and what we're going to do today is move this around. We're going to perform different transformations to this. So that is the vertex, is down here at the bottom, and the axis of symmetry of an absolute value function is the vertical line that runs straight through the vertex. And a lot of you have heard the term symmetry before, and what symmetry is basically what it means is mirror image, is that each side of this graph then is the mirror image of the other. Okay? So what we're going to do is perform different transformations to this. We're going to move it sideways. We're going to move it up and down. We're even going to what's called vertically stretch or vertically compress it. What that actually does is either narrow it, okay, bring these pieces closer together. That would be a vertical stretch. Or we're going to bring them farther apart from each other. That would be a vertical compression. So those are different things that we are going to do. Sometimes we're even going to flip it so it turns upside down. And that's another transformation that we can do to this. Okay, so the parent function, y equals the absolute value of x. What we're going to focus on first is the vertical and horizontal translations. We're going to look at one at a time, and then we're going to put those two translations together, and then we're going to look at the vertical compressions and the vertical stretch. Okay, so with the vertical translation is just a slide. We're just going to move it around, and if we add or subtract a number outside of the absolute value, that means we're moving it vertically. Okay? If it's positive value outside, we're moving it that many units up. If it's a negative or subtracting a value outside, then we are moving it that many units down. So the first two examples we're going to look at are cases of vertical translations. So this first one, we're going to sketch this graph. And again, just like with the lines, we're going to label all intercepts. That's x and y intercepts, and we'll talk about how to find those. And we're also going to give the domain and range of each of these functions. So in this first case, we're going to take this parent function whose vertex is at the point 0, 0, and we're going to slide it down 4 units because it's minus 4. So we're going to slide it down 4 units. So the vertex is now at the point 0, negative 4 instead of the point 0, 0. And then we're going to draw the V shape opening up. Now, nice thing about this is that the vertex and the y-intercept are the exact same point, but we do have a couple of points, x-intercepts, that we do need to find. Now, we have done this with lines before. Okay? At each of these points, we know the y-coordinate. That y-coordinate is 0. So to find those those x-intercepts, we're going to take the original equation and plug 0 in for y. And then we're going to solve it for x. That is what we did in the 1-6 worksheet, and you guys can solve equations like this. Okay, just a quick review of that. First thing we want to do is get the absolute value part by itself by adding 4 to both sides. So 4 is equal to the absolute value of x. So then this is basically asking what number is 4 units from 0? There are 2 of them. There's a number that's 4 units to the right, and a number that's 4 units to the left. For negative 4, and then your goal is to get the x by itself in the middle. It's already done for you. So here are our 2 x-intercepts, negative 4 and 4. Okay. So that is finding the x-intercepts. The last thing is the domain and range, which we have also talked about with graphing the lines. Again, the domain goes from left to right. So the domain, the left end, this keeps on going on forever. The left end of this graph is negative infinity. The right end of the graph is positive infinity. So that is the domain of these graphs. The range of these graphs and of any graph goes from the bottom of the graph to the top. Well, this graph has a bottom point. The y-coordinate at the bottom point is negative 4. And remember from before when we talked about domain and range, it includes negative 4, so we put a bracket around that negative 4. And then the top end of this graph goes on to infinity. So we've labeled all intercepts, and we've given the domain and range. Now in the second example, in this case we're moving it up 2 units. So when we take this vertex, which is normally at the point 0, 0 for the parent function, and we're going to move it straight up 2 units, that brings us up to the point 0, 2. And then we draw the V shape, and you'll notice that in this one, it does not have any x-intercepts, so we don't need to worry about finding the x-intercepts because there aren't any. And also the vertex and the y-intercept are the same point, so we only have that 1 point to label. And then we deal with domain and range. And once again, the domain goes from left edge to right edge. Left edge of the graph is negative infinity because it goes on forever. The right edge is positive infinity. And again with the domain, always go left to right. Now with the range, bottom to top. So the bottom part of this graph is at 2. Again, we deal with the y coordinates with the range, x coordinates with the domain. Now, since this one includes 2, we put a bracket around the 2, and the top of the graph is infinity. Okay? So that's dealing with the vertical translations of these graphs. Now, the horizontal translations are a little bit different. It's a little bit counterintuitive to what you might think. And if we are adding or subtracting a number inside the absolute value with the x, then that tells us that we are moving the graph left or right, horizontally. Now, here's the thing you have to be careful and pay attention to. If we are subtracting a value from the x, that means we are moving it to the right. Okay, it's a negative value inside. We're moving it kind of opposite what we would think, so we move it to the right. If we are adding something, then we are moving it to the left. For example, if we take a quick look at our second one and we enter an absolute value, and if we take x plus 2 inside those parentheses, and we hit graph again, you'll notice how it was moved 2 units to the left with the x plus 2. If we subtract the 2 and hit graph, there's the first one, the parent function, it ends up being moved to the right. So just be very careful. Again, with the horizontal translations, it's a little bit counterintuitive to what you would think. So, fast forwarding to the horizontal translations, this one, since we're subtracting 4 on the inside with the x, that means the vertex, which is normally at the point 0, 0, is slid 4 units to the right. So that vertex becomes the point 4, 0. And then we draw in the V shape. Now, in this case, the vertex and the x-intercept, which there is only one, are actually the same point. What do we need to find yet? We need to find the y-intercept. And again, we talked about this with the lines as well. To find this y-intercept, we know that the x-coordinate is 0, so we're going to substitute 0 in for x here. So y is equal to the absolute value of 0 minus 4. 0 minus 4 is negative 4. The absolute value of negative 4 is 4. So that is the y-intercept. Now we've labeled everything we need to. We just need the domain and the range. So the domain, again, left edge to right edge. Left edge of the graph is negative infinity. Right edge of the graph, positive infinity. And then the range is bottom of the graph, which is at 0, and it includes 0, to the top edge of the graph, infinity. And that is the domain and range, and we are done with that. And the last example, since we are adding 2 inside with the x, then we move it opposite of what we would think. It actually moves 2 units to the left, and the vertex becomes a point negative 2, 0. And then we draw the V shape so that it opens up, and we've got the x-intercepts taken care of, vertex taken care of. Now we just need to find that y-intercept, and again, x-coordinate is 0, so we're going to plug in 0 for that x. 0 plus 2 is 2. Absolute value of 2 is 2. So then the domain and range. Domain, once again, the left edge is negative infinity. Right edge is positive infinity. And then the range, Bottom is the point 0, again, y coordinate with the range. It includes 0, so we put a bracket around it. And the top is infinity. And then in the next two examples, we are going to apply both vertical and horizontal translations to these. In this first one, since we are adding 2, we have plus 2 inside, that tells us we're going to move it 2 units to the left. And we're adding 3 units on the outside, so that tells us we're moving 3 units up. So 2 units to the left, 3 units up. So the vertex gets moved 2 units to the left, and then 3 units up. So that point is -2, 3. That is the vertex. And it's a V shape that opens up. There are no x-intercepts to worry about. We have the vertex labeled. We just need to find that y-intercept. And to find that, once again, x-coordinate at the y-intercept is 0. So then we're going to plug 0 in for x. So we have 0 plus 2 is 2. Absolute value of that is 2. And then when we add 3, we get 5. So the y-coordinate is 5. And then we have domain and range. The domain, left edge to right edge, -infinity to infinity. You might be seeing a trend here. Well, that's long tail on the parenthesis. I can erase that. And then on the range, bottom to top, 3, 2, infinity. And it includes 3, so don't forget the bracket. Now, this last one that we're going to look at in this video is a little bit more involved because we're going to find a new vertex, we're going to have new x-intercepts to find, and also y-intercepts to find, one y-intercept. So to graph this, let's look at the vertex first. Vertex is normally at the origin. We're going to take that vertex and move it 2 units to the right. Remember, opposite of what you would think. So 2 units to the right and 1 unit down. So 2 units to the right and 1 unit down. So that becomes the point 2, -1. And then we draw the V shape. Okay. So we have 1 y-intercept to find and 2 x-intercepts to find. So in this case, let's find the y-intercept first. We know the x-coordinate there is 0. So when we plug 0 in for x, 0 minus 2 is -2. Absolute value of that is 2 minus 1 is 1. Now to find the y-intercepts, we know, or I'm sorry, the x-intercepts, to find those, we know that the y-coordinate at those points is 0. So we're going to plug 0 in for that f of x or y. So 0 is equal to the absolute value of x minus 2 minus 1. Now all we have is an absolute value equation just like we had in 1/6. So we're going to solve this. First thing we want to do is get the absolute value part by itself by adding 1. So 1 is equal to the absolute value of x minus 2. Once we have the absolute value by itself, then we can think about what numbers are 1 unit from 0. Well, there are 2 of them. One that's 1 unit to the right, and one that's 1 unit to the left, -1 and 1. So then we're going to solve this equation, get the x by itself in the middle by adding 2 everywhere. -1 plus 2 is 1. 1 plus 2 is 3. So there are our 2 x-intercepts. At 1, this one would be the 1 because it's to the left. This one would be 3. So there are the 2 x-intercepts. And the only thing that's left is the domain and range. Domain, left edge to right edge, -infinity to infinity. And then the range, bottom, which is at -1, and it includes -1, to the top, which is infinity. I know that was kind of a lengthy video. We've got one more to talk about today, and that is when we start applying the vertical compression and vertical stretch, and also perhaps some reflections.